Hello, this is Nikita Igorov, assignment 2, Comp 381, talking about regression. So the very first thing we do is we import the data, and we can look at the data, see how it is displayed. Then we can perform EDA. We can get some info about the data. We can see that every entry is not null. We don't have any missing values. All the data is numerical, so we don't have to enumerate anything. We can also graph these histograms of the data to see their distribution. Next, what I did is I made a scatter matrix of the correlation between each column to see which variable is most highly correlated with target. And from what it seems, it is BMI. So that's what I chose to split the data on, right? I'm using stratified shuffle split, and it's going to preserve the same proportion of these different BMI buckets in the training set and the testing set. So after that is done, I will remove the categorical variable from the data set, so it is not part of the regression. Here I will train a linear regression model. So I will get the training data, I will train it, and then I will use the testing data to make a prediction and see how accurate that prediction is to the actual targets. And you can see that the mean squared error for the testing data is 3,700. Mean squared error for the training data is roughly 2,800. So the training error is way smaller than testing error, which likely indicates overfitting. We move on to the ridge regression, which we do the same thing with, and we can see that the testing error is much closer to the training error. So this means that the model is like barely overfitting, which would make sense because ridge regression is just linear regression with regularization added on top of it, right? So we see an improvement of results when we go to ridge regression. We can then try a polynomial regression with degrees 3 and 5. So there's two models in here. And you can see that the degree 3 polynomial has the mean squared error of around 200,000. And the degree 5 polynomial has the mean squared error of around 850,000. So we could see right away that the polynomial regressors are overfitting the training data by quite a bit. And so I don't actually have the mean squared error for the training data, just because you can see that the model by design is overfitting. I have tested out a few of these values, and degree 1 has the best performance. That is, I think, exactly the same as just the linear regression, which again makes sense. Next, we try some nonlinear regressions. So here we're trying a support vector regression. And if we run it with the default parameters, these are the values we get. So quite a bit worse than the linear regression. However, I have tried out a few things. If you run it with the polynomial kernel and with the degree 1, it gets slightly better results than the ridge regression, right? So it's a bigger, more powerful model with more ways to tune it and more ways to optimize it. And then a similar thing with the random forest regressor. I've found that at 7 estimators it performs the best, but for the sake of this, we will try it with the default configuration. And so it gives us 3,600 for the testing error and 466 for the training error. So again, you could see this is severely overfitting, most likely. So that's the overview of every model. As I've mentioned, the nonlinear models are more robust, at least in this assignment, and with proper optimization, they will achieve better results than the linear models. However, at default parameters, the SVR is, you can see the SVR is not performing well, and the random forest regressor is severely overfitting the data. As far as improving the results, I think there are two major things to look at. The first thing would be to split the data into 3 categories. So instead of training and testing, you would split into training, validation, and testing, which would allow you to mess with these parameters to optimize all of your models to see what is the highest the lowest mean squared error you can achieve. Because right now, if I change these parameters based on the test results that I'm getting, the test set becomes invalid, right? It becomes a validation, and so my results become useless. And then the second thing I would do is I would experiment with the parameter you choose to stratify your data based on. Right, I chose BMI because of prior knowledge and the fact that it looks the most correlated to target. But you could also choose S5, which I believe is total cholesterol in the blood or something of the sort. Right, so you could experiment with that. You could get a subject matter expert to consult with you on which of these should be the biggest indicator. And yeah, thank you.